Hi everyone. We're going to analyze the graph of a rational function. This is number 8. We're going to go ahead and call this q of x. Make sure it's different. We have x to the 4th. This was a little similar to the number 7 we did. I'm going to go ahead and factor the numerator for you. And the denominator would be x minus 2 times x plus 2. I can't cross anything out, so if you look at step 2 here, it's already in lowest terms, so we don't really need to do that. My numerator I'm going to call p to the x. My denominator is q to the x. Oops, q, that's a q. Since the degree in the numerator is more than 1 higher, we have, for step 6, we don't have any horizontal or oblique asymptotes because n is greater than n plus 1. So my n, this is going to be n, is your numerator. 4 is greater than 2 plus 1 because my m is 2. So when it's greater than this, that means you have none. So we can actually skip step 6. And our domain, let's go ahead and do that one. You just set the denominator equals 0. And what makes the denominator 0 is x cannot be plus or minus 2. Alright? And since it's already in lowest terms, that means we don't have a whole because it's reduced. That means my vertical asymptotes are x equals 2 and x equals negative 2. So let's try to find the intercepts. We have the x-intercept is when you set the numerator. Let me write this out again. And I'm going to write it out in the factored form. Oops, yeah. So basically for your x-intercepts, you just set the numerator to equal 0. And what you're going to get is the x-intercepts are the zeros of p. P, the x, is our numerator. And that's going to be negative 1 and 1. This one is complex roots, so we're not going to deal with that one. That would be plus or minus I. So our x-intercepts are negative 1, 0, and 1, 0. So the q to the x, we're going to just let x be 0. So everywhere there's x, we put 0. And if I'm just going to use the original equation for that, so we have 0 to the 4th minus 1 over 0 squared minus 4. That's going to equal 1/4. So when x is 0, y is 1/4. Okay? Let's test for symmetry. Remember on that, you just input negative x. So I'm going to use my original negative x to the 4th minus 1 over negative x squared, minus 4. And when you simplify, you get x to the 4th minus 1 over x squared minus 4. Since this equals q, this is called q, sorry. Since this does equal q to the x, we get back our original equation. That means q to the x is symmetric to the y-axis, which helps us with our graphs. All right? Let's go ahead and you can put in the calculator if you want to. I'm going to go ahead and pick my intervals at my vertical asymptotes and also my Xintercepts. So I'm going to have several I want to see what's going on between certain intervals here. So I pick my interval here. I'm going to pick negative infinity to negative 2. I'm going to pick negative 2 to negative 1. You'll get used to this the more you do it. I'm going to pick negative 1 to 1, 1 to 2, and 2 to infinity. Okay? So basically, I'm picking negative 2 because that's the vertical asymptotes. So I'm picking negative 2 and 2. I'm also picking negative 1, and I'm picking 1 because that's the Xintercepts. And I want to know what's going on between both of these Xintercepts. So I want to know what's going on here and this side. And then I want to know what's going on from negative 2 to my first Xintercept and to my other intercept. And I also want to know what's going on between the intercepts. Okay? So let me just draw a line here. And I'm going to pick points in these intervals here. So I'm going to choose points. I get close to as negative 2 as possible. So I'm going to pick negative 3. Here I've got to pick a fraction here. So I'll just do negative 1.5 here. I'm going to pick 0. Since it's symmetric, this is going to be nice. I want to pick 3/2 here and 3 here. Now I have to find my value of Q, or your Y, by plugging in negative 3, all these points. It's not R, it's supposed to be what? Q, sorry. Q of 0, Q of 3/2, and Q of 3. And it's not as bad as you think. Since it's symmetric, we can figure this out. When I plug in negative 3, I get 16. This one, I get negative 2.3. 0 goes to 1/4, which we already knew that. Q of 3/2 is negative 2.3. And Q of 3 is 16. You're going to notice that these two match and these two match because it's symmetric. So I'm just going to determine if I'm above or below the graph. So location on the graph. I'm looking at my Y. Since it's positive, this is above the x-axis. It's going to help me graph. This is negative, so this is below. This one's going to be below. This one right here is above. And this is positive, so this one's above. So we have above, below, above, below, above. And then I'm just going to write down my points. I'm going to write down the points that I picked to graph. So this is the points on the graph. Points on Q graph. And we have negative 3/2. this one is, let's see, 3,16. Okay, let's graph it. If you already used your calculator, you're way ahead of me. So I'm going to draw in my intercepts, my asymptotes at x equals -2. It doesn't have any horizontal or oblique. X equals 2. I'm also going to plot my x-intercepts here. We had it at -1 and 1. And see, we knew what's above the graph and below. So the first, we've got 4 pieces here. I want to know what's going on here. So we had -3, 16. So I'm going to make my 8 a 16. So this is not going to be proportional. So I'm going to make that look like that. We're going to call this -3, 16. And that's going to happen over here as well. So this is going to be 3, 16. Now, the other points I had were 0, 1/4. So in this middle part, I had my y-intercept right in here. And so basically this is kind of going to go below the graph in here, goes up a little here, then it comes back down. Okay? And that is your graph. This point right here was 0, 1/4. So you see this is above the x-axis, above. These 2 pieces right in here are below. And we had that -2.3 thing going on. And there is your y-intercept that's above the graph. Thank you and have a nice day. Bye-bye.